Right guys, now let's work with another problem with four functions, basically using quotient rule and product rule together, basically. Right now we have I can say secant a power x, 1 plus x squared, and log x. These are the four guys. Now as the rule says, what we learned, we can differentiate only one function at a time. Now, what we're doing here is try to separate all these functions. That's the art of differentiation. So how do I start with? I can take this guy's numerator and denominator and see what happens here. How do you differentiate y is equal to numerator by denominator? It goes like denominator, d by dx of numerator minus numerator d by dx of denominator, the whole squared with d squared. Right? Cool. Very simple. Now who's denominator? This guy. That is, let me substitute this guy. That is 1 plus x squared into log x. Yep. Into differentiation of numerator would be, that is secant x into a power x minus, this minus comes here. Whose denominator? It is secant x into a power x, and differentiation of numerator. Who's that guy? Denominator. This guy is denominator. This guy is numerator into differentiation of denominator. That is 1 plus x squared into log x. That's what we have. The whole thing is divided by denominator squared. That should be 1 plus x squared into log x, the whole squared. Okay, that's what we have. Now, as we know, we can only differentiate one function at a time. I can see that there are two functions here now, right? Differentiation of secant x and a power x. So I can use the formula u into v here, that is product rule, and see what happens here. Let me write that for you. So the first part of it, I don't have any differentiation sign, so I have x squared into log x written just like that. And how will I differentiate this guy? I can see there are two functions. I can use UV rule, product rule here. So let me open a bracket. The first function, secant x into d by dx of a power x plus a power x into differentiation of secant x. Okay, that's how it is, right? Minus, here there is no differentiation sign, so I'll write secant x into a power x, and I'm differentiating who? These two guys. There are two functions, so I can use u and v rule here again. That is, let's open a bracket. 1 plus x squared, the first function is here, differentiate log x, yes, plus I can write log x and differentiate 1 plus x squared. Okay, that's what it is. Now see what happens. The whole thing divided by, I have denominator squared, that is 1 plus x squared into log x, the whole squared. Very simple, right? Now we can see there's differentiation for one single guy. We know the formula of a power x, that is a power x into log a. I know differentiation of secant x, yes. I know differentiation of log x and 1 plus x squared. So basically, we again made all these functions separate, right? Now, see what happens here. You can do it. You can pause the video and try doing it. Do a couple of more problems. You can choose your own problems, all right? So here I can write secant x into differentiation of a power x is a power x into log a, right? That's it. This we already know from those formulas we learned, right? That's all is differentiation. Plus a power x. And how do you differentiate secant x? That is secant x into tan x. Yes. Then what about this guy? That is secant x into a power x. Then here I have 1 plus x squared. No differentiation sign. Here it becomes 1 by x plus log x. And how do you differentiate 1 plus x squared? That is 2x. That's it. The whole thing divided by denominator, that is 1 plus x squared into log x, the whole squared, and that's all the problem is. Very simple. So far, let us just revise what happened. So we learned how to differentiate right from the starting, and the rule was we can differentiate one function at a time. So we went on to product rule, where we had two functions, so we used product rule, separating these two guys. Then we had quotient rule, then we had combination of quotient and product. Now this guy is two product rules here in one quotient rule. So we could actually separate all the four guys separately, and here you can see differentiating is only one function at a time. A power x here, secant x here, and log x here, and that further. So remember this, differentiation is all about separating functions. That's it.